All right, so here in this video, I've got a wonderful triangular pyramid, and I'm going to figure out all the things I can about it, just armed only with my ruler and a calculator. So the first thing that I'm going to do is just measure all of the different um, edges, because the edges are the easiest for me to measure. It's kind of harder to measure along one of the other sides because I just don't know exactly how to hold my ruler. So we're going to measure the edges. So when I measure the edge, the slant edge like this, it's about 18 centimeters. So let's try to draw this shape. It's got a triangular base, and then it comes up to a point like this. So this measurement is 18 centimeters, and it's the same on this side here, and it's the same along the back as well. Then along here, this I think is equilateral. Let's double check. So that comes out to be 16 centimeters. Yeah, by 16 by 16. So along the base, we have 16 centimeters here and also right there. So what we can do now is figure out any of the other pieces of information that we want just using our triangles. So when I look at the base of it, I've got 16, 16, and 16. And so because that is the same on all three sides, that forces the three angles to all be the same. And so the three angles all need to be 60 degrees because um, 60 plus 60 plus 60 makes 180 degrees. So if I wanted to find, say, the area of the base, so I'll call the area of the base, that would just be 1/2 times A times B times sine of C, or 1/2 times 16 times 16 times sine of 60 degrees. Just type that into the calculator. Oops, there you go. And here's what it looks like. 110. So that's the area in square centimeters of just the base. So that's not surface area. I'm just finding the base that's colored red on this shape. I'll go through and try to find the other pieces now. So I'm going to use a different color so you can kind of keep track that the red triangle here was the base. The other triangles are a little bit different. They have 18 centimeters, 18 centimeters, but there's 16 centimeters across here. And so I don't know anything about the angles just off the bat because it's not a equilateral triangle. I do know that these two angles here need to be equal to each other, but this angle over here is going to be different. So I can't just off the top of my head get it. So what I can do though is use our good friend, the law of cosines, to figure it out. So let's set up law of cosines. I'm going to call this angle C, so I can call these A and B, and set up A squared plus B squared minus 2AB cosine C equals C squared. We've got three different chunks of this that we can calculate. Remember, you can't type it all in at once because you don't know the angle C. So we're going to actually work backwards here to calculate what the angle C is. So we have 648 minus 648 cosine C. Don't try to subtract those because then you'll get 0 on the left side. And then 16 squared is 256. So imagine you had 648 minus 648x. You don't subtract the two 648s from each other. You try to move stuff to one side of the equation to isolate the part you actually care about. So 256 minus 648 is negative 392. Divide that by negative 648, and you get cosine of C is 0.605, rounding it off to 3 significant figures. But I'm going to actually use the exact answer on the calculator. So it's a nice way to be more precise, is keeping the exact answer. So inverse cosine there tells me C is 52.78. I'll go 4 significant figures. So if I know that that's angle C, and then I can take that away from 180 to figure out what angles A and B are. So I'm doing 180 minus the answer to keep it more precise. Equals 127.22. Oops. I wrote the answer. I meant to write my step here. 180 minus the angle I just figured out. Let's move my face out of the way. So that's going to equal 127.22. Remember, but that's equal to the other two angles, and the other two angles are equal to each other, so I got to divide that by 2. So if we take 127.22 divided by 2, 63.61. And so that's equal to angle A, and that's also equal to angle B. Okay, now that we have that, what can we figure out? So we want to figure out the area of these triangles, because then once we have the area of this triangle, we can get the area of the entire shape, the surface area of the entire shape. So we can use angle C along with the two sides of 18 here to find the area of, we'll call it a side, or maybe a slant face. That's going to be 1/2 times A times B times sine of C. Let's just type that in, see what happens. Gives me 128.996. It's good that I got a slightly bigger answer because the base is slightly smaller than one of these sides, so I knew it should be a little bit bigger. So then my total surface area is going to be the red base, and then I have 3 of the clear triangles. So it's going to be that red answer we calculated a few minutes ago, plus 3 of the things we just calculated. So 110.85 plus 3 times the answer I just got tells me my total surface area for this shape, 497.84 square centimeters. All right. So the only other thing that I want to figure out here is the volume. And when you find the volume of a shape here, what you need is the true height and then the area of the base triangle. So I already have the area of the base triangle. What I need to know is what is the true height. And so the true height is a little bit tricky, but what I can do is use the 18, which is along this slant height, and use half of this. If I find what is normally called the height, you can call it maybe the altitude of the red triangle, if I can go halfway across that goes right underneath the tip. So that would form a right triangle. So I'm going to erase a little bit of this work right here and try to show you what I'm going to do. So if I go halfway along the red triangle and then use the slant of 18, that forms a right triangle where the true height is missing. So all I need to do is find this distance right here on my red triangle from top to bottom. Well, I know I have 16 here and I have 60 right here, so I can use sine to find that. I'll call that little h. So sine of 60 degrees equals little h over 16. So I just need to go 16 times the sine of 60 to get my little h. Gives me 13.86. Then that's one of the legs, and 18 is the hypotenuse. So we have 13.86 squared plus big H, that's the true height, equals 18 squared. So I'm going to go 18 squared minus the number I just found squared. That gives me, that's really nice, it worked out so nicely. It gives me exactly 132. Means that the true height, not it is the true height is not 132. The true height is the square root of 132. And so the true height comes out to be about 11.49. Let's just check that with the ruler. Does that even seem reasonable? The true height is 11.49. Looks pretty good. So then where am I at? I want to find the volume of the whole shape. So the volume of the whole shape is going to be 1/3 times the area of the base times then where am I? 1/3 times the volume of the base times the true height. And if you type all that in, you get 424.52 cubic centimeters right there. So there we go. We used a lot of different triangle tools to figure out all of the different measurements of this triangular pyramid. All right, please ask questions or comments if anything was confusing.